Hey everybody! So today I want to teach you guys about reflections. Reflections and transformations has another word. We say the word flip. Flipping things over lines, reflecting things, like a mirror image. So for example, when you look in the mirror in your house, you see your reflection. When you raise your right hand, your reflection raises their left hand. The hands don't change size. They don't change shape, they just change the direction. They're opposites of one another. So I'm making this video to show you what a reflection is, how it works, so that this week you can practice doing reflections. Okay, so let me shrink myself down. And I have here an L. I made an L, and I can move this L around. This is in a program called GeoGebra. It's a nice program, I like it a lot. But I can move this L around here. Now, in order to reflect something, you must have a line. You have to reflect it over a line. Okay? So I want to make a mirror image of this L over here. So, up here, I just hit reflect, and reflect this shape over this line, and ta-da! I have here a reflection of my L. Notice they're the same size. They're the same shape. Nothing changes. The only thing that did change, though, is the direction. They're opposites of one another. Now, here's the important part. When you reflect across the line, the distance between the line is the same on both sides. So watch. When I move the left side closer, the right side moves closer. When I move the left side back, the right side moves back. I can go up and down, and it copies every movement, and the distance between the lines don't change. Now look at this. I can cross through the line, and the reflection still remains the same. They reflect over that line. Now, this is with a vertical line going up and down. What if I made this line horizontal? Oh, a little bit trippy there. Notice I kind of took it through it. It's the same way. Same distance above and below. If I move it left, right, they follow one another, and the shape stays the same. And again, you can go through a shape or reflect over the line. You can even do it diagonally. This gets a little bit tricky though, because it almost looks like it rotates it. But if you look at it, the distance from this corner to the line is the same on both sides. And again, if you move it around, that distance is always the same. So that's what a reflection is. Now I'm going to show you how you do it using a grid. Okay, so now let's say I have this grid here, and this is my line I want to flip over. So if I make this shape right here, we'll do a triangle. If I wanted to flip this triangle over that line, so it becomes a mirror image, I must remember the distance. Each point, the distance from the line is the same on both sides. So for example, this point is 2 spaces above the line. It's going to flip and go 2 spaces below the line. 1, 2. So A, we'll say that point is A. It will land here, and we call that new point A prime, to tell us this is where we started and this is where we ended. If this is point B is 1, 2, 3, 4, 5 spaces above the line. So it goes 1, 2, 3, 4, 5 spaces below the line. And B will flip over and land right here and be called B prime. C is 2 spaces above the line. It'll flip over and be 2 spaces below the line, calling C prime. And if I connect the dots, I have created the exact same shape, the exact same size, but a reflection of itself over this line. Okay? Let me do another one. Let's do our L. So if I wanted to do this point, this right here, each point is the same distance on both sides. So if it's 2 up, it goes 2 down. Again, if this was A, it would become A prime. 2 points up, 2 points down. 1, 2, 3 points up, 1, 2, 3 points down. 1, 2, 3, 1, 2, 3. I'll do this point up here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if I connect the dots, I've created that exact same L, just a reflection of itself over that line. So that's what reflections are. I'm going to have you guys practice these today on a worksheet to see if you understand how they move across lines by counting, and then we'll get down into the nitty-gritty math here later. See ya!